Okay, we're going to talk about even and odd functions now. I'm going to plug some numbers in and give you some examples, and then I'm going to show you the definition of an even function and the definition of an odd function. So let's look at f of 2 here. That would be 5 times 4 plus 3, so that would be 24. So f of 2 is equal to 24. If I do f of negative 2, that's still 5 times 4 because it's negative 2 squared. So 5 times 4 is 20. I get, apparently I can't add. So 20 plus 3 is 23. Let's try that. Okay, so 5 times 4 is 20. Again, plus 3 is 23. So f of negative 2 is equal to 23. Okay, so I'm going to draw some attention to this here. F of 2 is 23. F of negative 2 is 23. Okay, let's come over here and do f of 1. So 2 times 1 cubed plus 1 would be 2 plus 1, which is 3. So f of 1 is equal to 3. Let's plug in f of negative 1. That would be 2 times negative 1 to the third plus a negative 1. So that would be negative 1 times 2. So that would be negative 2 minus 1. So that would equal negative 3. So f of negative 1 is equal to negative 3. So let's draw attention to that. We have f of 1 is equal to 3. F of negative 1 is equal to negative 3. Let's do f of 5 over here. That would be 15 plus 8, so that would be 23. So f of 5 is equal to 23. Let's do f of negative 5. That would be negative 15 plus 8. That would be negative 7. So we have f of negative 5 is equal to negative 7. So let's draw attention to that. F of 5 is 23. F of negative 5 is negative 7. Okay? So the definition of an even function is that f of negative x is equal to f of x. The definition of an odd function is that f of negative x is equal to negative f of x. So f of 2 and f of negative 2 represent f of x and f of negative x. So this means when you change the sign of your x, and we did that, we got 23 both times. So that means this is an even function. F of negative 2 equaled 23, and f of 2 equaled 23. So 23 equals 23, that is an even function, okay? Over here, when I change the sign of my x, okay, so f of negative x and negative f of x, when I change the sign of my x, so this would be like f of 1, this would be f of negative 1, I get the opposite answer. F of 1 is 3, and if I put a negative in front of 3, that's what I get when I plug in my negative. Now, don't think of these as necessarily negatives. These mean the opposite. So it turned out that way that, you know, when I plug in 1, I get a positive number, and when I plug in negative 1, I get a negative number. It doesn't always work that way. It just means the opposite. When you change the sign from 1 to negative 1, you change the sign from whatever answer this is to the opposite. If this would have been negative 8, then this would have turned into a positive 8, okay? But the point is, when I change the sign of my x, I get the opposite answer. So that's an odd function. Now, most functions are not even or odd. Most functions, something like this happens. I plug in 5, I get 23. I plug in negative 5, I don't get 23, and I don't get negative 23. I get something totally different. So this is neither even or odd. This one is odd, and this one is even. Now, they're called that because of the exponents. It takes even exponents for the negative to not matter. In order to plug in x or negative x, to plug in a number or its opposite and get the same thing, the negative must not matter. So if you have an even exponent on all of your x's, it will cancel out the negative. And a constant is like an even, because technically this is like 3x to the 0, okay, and 0 would be an even number. But you can just remember that when you plug a negative in, like when I plugged in -2, it didn't change the +3. That constant doesn't depend on whether I plug in a negative or a positive x value. So a constant acts like an even. Over here, 2x cubed, well, 3 is an odd power. And this isn't written, but it's really 1. This is really 1x to the first power. So I have an odd. All of my exponents are odd. Okay? So over here, I have an odd, and then 8 acts like an even. So when I mix it together, I get neither. Okay? Now, I'll give you a couple for you to try to determine. So let's say f of x is 3x squared plus 2x minus 5. You can just plug in -x. You don't have to actually plug in a number. If you want to plug in a number, plug in 1, -1, plug in 2, -2, you can. But you can just plug in -x. So 3 times -x squared plus 2 times -x minus 5. Well, that's going to become 3x squared because my negative is going to cancel. But that negative isn't. It's going to be minus 2x and then minus 5. So this is different than that. It's not exactly the same. It's not exactly the opposite. So this is neither. Okay? Let's try something else. F of x equals 7x to the 4th minus 3x squared. Plug in f of -x. Okay? So 7 times -x to the 4th power minus 3 times -x squared is going to reduce to 7x to the 4th minus 3x squared. So that is the same as the original. So f of x equals f of -x. So this one is even. Fractions are a little bit harder. Well, let me show you another odd before I show you fractions. So let's say we have f of x is equal to 2x to the 5th minus 8x. So plug in f of -x. So that's 2 times -x to the 5th minus 8 times -x. So 5 negatives is going to make a negative. So -2x to the 5th. 2 negatives make a positive. Well, this is exactly the opposite of this. And if you need to see that, you can factor out a negative. 2x to the 5th minus 8x. So f of x and f of -x gave me the exact opposite. F of -x is the opposite of f of x. So this is odd. Okay, so fractions are trickier. Let's say you have x squared plus 4 over x to the 3rd. Okay,